So, students, this is question number 6 from the first exercise of permutation and combination. See, what is this question number 6 saying? These problems are based on fundamental principle of multiplication or fundamental principle of addition. That is principle of counting. Look at this question number 6. What does it say? It says that a letter lock has 3 rings and each ring has 5 letters. Determine the maximum number of trials that may be required to open the lock. Now, see, students, you must have seen, in the briefcase that you have, the briefcase or the suitcase. So, in those briefcases or suitcases, we have locks, and those are sometimes number locks or letter locks. So, this time, you know what? It is letter lock. So what normally you do, you fix up a code. So, there are 3 rings in the lock as per the given instruction. So, there are 3 rings. This is say 1 ring, this is second ring and the third ring. So, there are 3 rings. So, what is visible to you? This is the briefcase that you have. And what happens? This is briefcase, and when you fix the correct code, on the letter lock, then it will open. Okay, the briefcase will open. Hetek, hetek, and you can take the chocolates from the briefcase or whatever. So here, students, see, there are 3 rings. Now, what are they saying? That each ring has got 5 letters. So I shall make the rings here. They are saying that each ring has 5 letters in it. So this is the first ring, this is second ring and third ring. So each ring has 5 letters. So suppose I have here A, B. What about C, D and E? It is on the back side, it's a ring, no? So it's going like this. It's not visible to us. It is on the back side. Then here, it's a ring. It's a circular ring, my dear students. So what is on the back side, we don't see. We see only the front side. Okay, it's hidden. Then here you have C and D. And here you have E and A right here. So, each one has got 5 letters. There are 3 rings and 5 letters. Now, the question here, it says, determine, see, the question is determine, that is find out the maximum number of trials that may be required to open the lock. Now, what happened, you do not know what is the correct code. Say the correct code I have, some code I have fixed, but I did not reveal it. And you still want to open this box. You still want to open this box and get the chocolate out of it. What you will do? You will start doing all the combinations. You will go for A, then next A, B, then next A, C, then next A, D, then next A, E. You got that? So what you did? This two you kept A, the first and the second ring, and on this you went for all the 5 different letters. Then you will go for A, B, A, and all that. So this is 5 here. The question here is how many such trials you are going to make, and what will be the maximum number of such trials? That is what they are saying. They are saying what will be the maximum number of such trials. Okay. See, students, in order to get the maximum number of such trials, you know what I will do? I shall find out the total number of 3-letter codes which are possible. What I will do? I will find out total number of 3-letter code. Okay, so here see my answer will start. See, till now, whatever I was doing, it was just an explanation. The actual answer I'm starting now. See, I will write as a three-letter, I'm sorry, a three-letter code can be in the can be given as follows. It can be given as follows. See, a three-letter code. This is first letter, third. First, second, and third. Right? Now see. Now tell me, for how many total different codes can be made? How many total different codes can be made? That we will find. See here. The first position that you have of the three-letter code, the first letter, that is first position that you have, it can be chosen in five ways, five different ways. Yeah. So I will write here. The first letter, the first letter can be selected in five different ways. Fine. After selecting the first letter, see, you have A, B, C, D, E. So from five, you can select any one for the first letter. Okay. Now you are going for the second letter. That is the letter in the second ring. Okay. The letter in the second ring. The first letter, now the second ring. The letter in the second ring, again, you can select in five different ways. Again, five. You can have any. After selecting the first letter, you can select the second letter again in five ways. And what about the third? Third is also in five ways. Yes, so I will write here. And the second and third letters, now I'm writing both together. And the second and third letter can be selected in five different ways. Five different ways each. So see, students, after selecting the first letter, you went for the second letter, and then after selecting the second letter, you went for the third letter. So see how are we doing it? Selection of the first letter and selection of the second letter and selection of the third letter. You see this? So it is and in between. So what does it mean? Therefore, all the three letters can be selected in how many ways? 5 into 5 into 5. 5 into 5 into 5. So I'll write here. Therefore, the three letters together, that is one after the other, together can be selected in 5 into 5 into 5 ways. Okay, what is 5 into 5 into 5? 125. So next step I will write now. Therefore, I'll write the next step here. Therefore, 125 different three-letter codes can be made. 125 total three-letter codes can be made. Now see, students, so there are total 125 possible codes. How many codes, three-letter codes are possible? 125, or password, whatever you say. 125 passwords are available from three rings, each having 5 letters. Now, in order to open this, what you are doing? You are just manipulating, trial and error method. You are playing a trial and error game. You're just trying, you're just trying. So if you are fortunate, you are lucky, you might get the correct code in the first, in after some trials. And if you are very unfortunate, what will happen? You will have to go for all trials. So what will be the total number of, what will be the maximum number, what will be the maximum number of trials that before you open the lock? The maximum number of trials before you open the lock is going to be 125. So I will write here, therefore, maximum number of trials equals to 125. I hope you all followed it. Okay, I was on mute, so I will repeat once again. See, students, you know, if the question had been, if there is a small change in the question, if the question, same question, slightly modified. If they ask me, determine the maximum number of false trials that may be required to open the lock. Okay, if they're asking you the maximum number of false trials. Now see, when they say false trials, what change do we have to bring in? In the earlier case, we found the maximum number of trials. You had to go for 125 trials, that is equal to all different codes. There were total 125 codes, and you had to try all 125 codes. That was the maximum number, because you were not that lucky. You are not that lucky to have opened it, because see, you didn't know it. You are just trying, and you were not lucky. So you had to try all. So this is maximum number of trials. Okay, this is maximum number of trials. Now remember, students, in these trials, one code is the correct code, that is true code, and remaining are the false codes. You understand? In 125, there is one code which is true code, and remaining are false codes. So what will be the maximum number of false trials? 125 minus 1. So I will write, therefore, maximum number of false trials equals to 125 minus 1, that is 124. I hope this is also clear to you all. Okay, see, students, question number 7 is very much similar. I will not say that it is going to be exactly the same way, but then it's quite similar. It's very much similar to question number 6 that we just now solved. We solved. See, what is question number 7? It says, in a test, 5 questions are of the form state true or false. What is the form of the question? The form of the question is straight. You have to state true or false. You have to state true or false. State true or false. So there are 5 questions. I will give you the hint. Question 1, question 2, question 3, question 4, and question 5. These 5 questions are of what form? The form is very simple, state true or false. It means, their answers are going to be only true or false. That's it. The answers are going to be only true or false. Understand this. So the answer, the answers are going to be only true or false. So suppose question one is someone, so the question one will be like this. New Delhi is capital of India. True or false? The answer is true. Okay, Aurangabad is in Jammu and Kashmir. False. Question number three. Indira Gandhi is grand. Indira Gandhi is grandmother of Rahul Gandhi. True or false? True. Okay. And like this, fourth and fifth. So say one false and this is also false. Like this. So there are five questions, and all the five questions are of what form? State true or false. So suppose this code which this particular answer, the sequence of answer that you see right now, TFTFF, this is the correct sequence, TFTFF. If somebody is writing this code, I'm sorry, if somebody is writing this sequence, they get all correct. So this is how it is. Now see, let us read the question ahead. It says in a test, five questions are of the form state true or false. Then it says no student has got all answers correct. No student. What does it mean? See, students, if this is the correct sequence, nobody, not a single student has written this sequence. TFTFF, not a single student has written this sequence. Now let's go ahead. What is next? It says also the answer of every student is different. Not only that, they are saying the answer is also different. Okay, that is, say this nobody wrote, this nobody has written first, and second, Amar. The answer of Amar, the sequence, first thing is what? The sequence of Amar is not this. Amar has not written the correct sequence. Second, what Amar has written, Vipin has written different. For Vipin, the sequence is different. Then Jyotsna, Jyotsna has written the sequence different. Okay, she has written different. Like this, there are many students, and they are saying that nobody has written same sequence. That is what it says. See, clearly it has stated what it says. Also, the answer of every student is different. Now they're saying find the number of students appeared for the test. Now they are asking you how many students were there for the test. Okay, so I have explained this to you. These students, I've explained everything now. You can't complain. You have to solve this. Question number 8. I'm taking now 8 question for you. Let's begin solving question number 8. Let's start solving question number 8. The 8th question is, how many numbers between 100 and 1000 have 4 in the units place? So the question is, I read it once again, how many numbers between 100 and 1000 have 4 in the unit place? Okay. So see, students, how will I begin? I will write my answer. See, this question here, I can frame it in a different way. I can frame it in a different way. Okay. Okay. Before that, just tell me between 100 and 1000, between 100 and 1000, the numbers you have, try to understand the question. Between 100 and 1000, the numbers that you have, what kind of numbers are those? Those are 3-digit numbers. They are 3-digit numbers. What are they saying? They're saying how many numbers, see between 100 and 1000, there are many numbers. They're saying how many of those numbers will have will have 4 in the unit place. They will 4 in the unit. Here it has to be 4. Here it has to be 4. That's it. 4 in the unit place. You cannot have 5 in the unit place. You have to have 4 in the unit place. They haven't said anything about the tens place, huh? Please. This is units place. This is units place or ones place, whatever you say. This is tens place. They're not saying anything about this. It means what? Here you can have 4, you may not have 4. They are not saying anything about hundreds place. No, hundreds place also they are not saying anything. You may or may not have 4. But yes, this has to be 4 mandatorily. Mandatorily. So this is what you have to go for. Okay. Now tell me students, if I say that for these all numbers between 100 and 1000, what are the digits that we are going to see? We are going to see 3-digit numbers and they all are going to use, all different digits. Like you will have 3-digit numbers which will involve 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all these. So suppose, I have a number here which is 374. See, 374. This is the number that they want. I have a number here, 894. See, this is the number that they want. I have a number here, 944. Yes, this is the number that they want. I have a number here, 204. This is the number that they want, like this. So they're saying how many numbers are there. Such numbers which have 4 at the unit place. Now see students, the same question, I put it in a different way. See, the same question can be asked like make a 3-digit number. The same question can be asked like make a 3-digit number using the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Make a 3-digit number using these digits such that the unit place is always 4. The unit place is always 4. Same type of question. Okay, see, whatever here they have said, I'm saying the same thing, but in a different way. So this thing, when I put it in a different way, now I understand it well. Why? Because now I understand what is my work. My work is to make a 3-digit number where the unit place is always 4. You see this? The unit place is always 4. So see here, I will write. The unit place can be selected in one way. Is my work done? Can I now go to my village? Can I now go to my village? There is a big fair, okay, in my village. So can I go to my village? Tell me. No. Why? Because the work is not over. You have just selected the units place. Now see, I will go to after unit place. Now I will go to hundreds place. Why? Because there is a condition. See, I will write the 100 place cannot be 0 because it's a number between 100 and 1000. How can you have some number starting with 0 between 100 and 1000? So you will say the hundreds place can be selected in, see, the hundreds place can be selected in 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 ways. It can be selected in 9 ways. Can we have 4 here? Why not? Why not? You can have 4 here. They are just saying that the number should have 4 at the unit place. Tens and hundreds, it may or may not be 4. Okay, so 9 ways for this. Now I come for the tens place. So hundreds place can be selected in 9 ways. Now the tens place, see here. The tens place can be selected in how many ways? See here. For tens place, I have got 10 digits. It can be any one of these digits. So I will write 10 ways. Okay, so see here. Now I have done all my job. See, I selected 4 at the units place as per the condition, that is in one way, and 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 I selected the hundreds place in 9 ways, and 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 the tens place in 10 ways. You understand? I was saying that and like a mad 3 times. Why? Because I know when it is and, it is going to be multiplied. You got that? So what will happen? The total number of ways is, how many ways you can do this thing? You can do is 9 into 10 into 1. That is 90. 90 different ways you can do this. It means how many numbers are there? The required numbers are 90. So we will say there are 90 numbers between 100 and 1000 which have 4 in the units place. I hope it's clear to you all. I will write the answer. A number between 100 and 1000 is a 3-digit number. Is a 3-digit number. Then a 3-digit number is given as follows. As follows. Here you will make a 3-digit number. You will write units place, tens place, this is hundreds place. Okay, and after this, I have taught you everything. Okay, you will follow the idea and you will complete this answer. You know what? You will write, you know the job that you have to do. I told you every time, students, see, you have to see that, you have to consider that you have to do this job. So you are going for unit place. Unit place can be selected in one way. Okay. What are the, okay, one more thing you can write. The digits to be used for making the digits to be used for these 3-digit numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now after this, see, units place has to be 4, so units place can be selected in one way, and then this, and then this. I just explained, you will complete it. Okay, now let's have question number 9, students. See, as I explained you 8, the ninth is also going to be on similar lines. See, question number 9 is, it says, how many numbers between 100 and 1000 have the digits 7 exactly once? Oh, great. Between 100 and 1000 this time, once again, you have numbers between 100 and 1000. You see this? Between 100 and 1000. And what they are saying, how many of these numbers between 100 and 1000? So see, 100, 100 and 1000. Got that? So after 100, you have 101, 102, 103, 104, da, 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 da. So many, then here you have 99, then 998, then 997, and so on. Now there are plenty of numbers. What are they saying? They're saying that how many of these numbers have digit 7, exactly once? You know what? It means they're asking you a number like 107. Yes, this number. But not 177. No, not this number. Why? Because in this you have 7 two times. Two times they don't want. They want just exactly one. Then 237. Yes, they want. then 752 they want, see exactly once, then 8, then 979 they want exactly once, like such numbers they want. So that 7, what I noticed that exactly once means the 7 can be at units place, it can be at tens place, it can be at hundreds place. Okay. So here once again, what I will do, student, I will try to frame the question for me in such a way so that it puts me on a task. I understand that this is my work to be done. Okay, so see how do I do it. Students, the same question, if it is framed, make a three-digit number, make a, how many three-digit numbers can be made? How many three-digit numbers can be made using the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9? Okay. How many three-digit numbers can be made using these digits if the digit 7 has to occur exactly once? Digit 7 has to occur exactly once. Got that? So now I understand what I have to do. I have to make a three-digit number and I have to see that 7 is exactly occurring once. That is, if 7 I am having at units place, then not at tens, not at hundreds. If I am having it at hundreds place, if I'm having it at tens place, then not at units, not at hundreds. And if I'm having it at hundreds place, then not at units place and not at tens place. Okay. So now I will go ahead. See how do I write my answer. I write, see, first of all, I will start writing as, I will write a number between 100 and 1000 is a three-digit number, is a three-digit number. Then I will write a three-digit number is given as follows. A three-digit number is given as follows. How is a three-digit number given, my dear students? See. All right. This as units place, this as tens place, and hundreds place. Hundreds. Now, see, students, there are going to be three different cases, There are three different cases. Why three different cases? Because, see, we have to get that 7 exactly once. So, case one will be when 7 occurs in units place, in or at, whatever, it's okay, That much English is done. That much English is permitted in mathematics. So when 7 occurs in units place, this is case one. So case one, see. Then, so this is first case. What is first case? When the 7 is occurring in units place, my dear student, see. When 7 occurs in units place, but remember, you have to still make a three-digit number. And what are the digits to be used? Please, what are the digits to be used? The digits to be used are, I can write here, the digits to be used, the digits to be used are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now see, if you ask me, how do you know that these are the units, these are the digits to be used? Come on, between 100 and 1000, those three-digit numbers you have, don't they use these digits? What else do they use? What else do they use? They use these digits only. So what I will now write, I will write here when 7 occurs at units place. So see here, I will write, therefore, the units place can be selected, can be selected, can be selected in one way. Okay, students, I got this fixed one way. Now tell me, after this, where I will go? I will go for the hundreds place. Please don't go for the tens place. You should go for the hundreds place first because there is a condition. What is the condition? It should not be zero. Okay. See, the hundreds place, you cannot have zero and you cannot have seven also. Why? Because seven you are already putting at units place. You cannot have seven there. Otherwise, there will be two sevens, which is not permitted. So I will write the hundreds place can't be zero, can't be zero. Okay, I will write therefore the hundreds place can be selected, can be selected in, see, it can't be zero, it can't be seven. So how many ways? 8 ways can be selected in eight different ways. 8 different ways. Now I come for the tens place. I will write here the tens place can be selected in, can be selected in. My dear students, see, can I have zero at tens place? Oh yes, definitely, but I cannot have seven because I have already put that seven at the units place. So how many ways? 9 ways. Okay, zero can be there. Only seven cannot be there. So from these 10 digits, only seven, that is one digit can't be there. So 9 ways. So I will write, therefore, the tens place can be selected in 9 different ways. It can be selected in 9 different ways. Okay. So total how many? You can check. You can check. I'll write here. Therefore, total. See, what is the work that you did? You selected this unit place in one way and and 100 in 8 ways and tens place in 9 ways. So total, in how many ways you can do all these three? 1 into 8 into 9. Okay, therefore total 1 into 8 into 9 different different three-digit numbers with with 7 at units place, 7 at units place can be there or can be there, can be made. That is what. Okay, that is equal to, that is equal to 1 into 8 into 9 is 72. See, what is the number? 72. Now I will go for case 2. I will go for case 2. In case 2, I will write when 7 occurs at tens place. Then case 3, when 7 occurs at hundreds place. Let me see. Students, you will pause the video and then you will solve this one on your own. Then come back and watch the video. So the second case will be, see students, now I write case 2. I write case 2. Case 2 is when when 7 occurs, when 7 occurs in when 7 occurs in tens place. See students, when 7 occurs in tens place, how the scene will change. See what I will write when 7 occurs in tens place. What will I write? See here. I will go by priority wise. The first thing that I will do is I will put the 7 in tens place. So see, the tens place can be selected in one way. Tens place in one way. But that I am not writing complete. That you will do. That is, you will have to write the tens place can be selected in one way. Then you go for the next priority, hundreds. What you will write? Hundreds place, okay, can't be 0 and it can't be 7. So hundreds place can be selected in in 8 different ways. 8 different ways. Guys, after this we have the last one, units place. I'll write here. Units place can be selected in. Now see, for units place, I cannot have 7, but I can have 0. So again, 9 ways. In 9 different ways. In 9 different ways. So therefore, total 3-digit numbers. Digits, total 3-digit numbers. Total 3-digit numbers with 7 at tens place. 7 at tens place will be how much? My dear students, it is going to be 1. It is going to be, it's gonna be 1 into 8 into 9. That is 72. 72. So see, this 72 will be added with this 72. Remember, here, this is going to be principle of addition between these two. Okay, fine. So you got 72. Now you will go for case 3. Come on, students, complete case 3 on your own. Yeah, students, let me write the third case here. I will write third case. Third case. So, see, I'll write here case 3. Case 3, when 7 occurs at hundreds place. So I will write here, hundreds place. Hundreds place can be selected in one way. Okay. Tens place can be selected in 9 ways. Here, the tens place cannot be 7. Rest, it can be all. It can't just be 7. Rest all. So that is 9 ways. And then you have units place. Units place can be selected in 9 ways. You got that. So therefore 1 into 9 into 9, that is different, 81 different three-digit, three-digit numbers with 7 at hundreds place can be formed. Hundreds place can be formed. Now, what were they saying? They were saying that total how many are there? Total how many three-digit numbers are there such that 7 occurs only once? So see, you have found all the possibilities. So what you will do? 72 plus 72 plus 81. Please add it, students. Right. Therefore, the total number of three-digit total number of three-digit numbers having 7 only once is equal to 72 plus 72 plus 81. That is 225. That is 225. I'm not writing it, that you will have to write. That's final, final statement you will have to write looking from the question. See what the question was. The question was how many numbers between 100 and 1000 have digit 7 exactly one. So you will write therefore you will write 72 plus 72 plus 81, that is equal to 225 numbers are there between 100 and 1000 having 7 exactly once. You have to add this with this with this. These are independent three cases. I hope it is clear to you all.